Hey everyone, it's Mr. Anderson one more time. Today we're going to be in section 2.2.2 of our CPM CCA Common Core Algebra book, and this is going to be day one of a 2-day lesson. And what I'm going to invite you to do, because I think it's worthwhile for the purposes of problem solving, critical thinking, and just digesting some of the concepts we're going to talk about here, I'm going to invite you, rather than do day one and day two consecutively, then try all the homework at once, or try all the formative practice at one time, I'm going to invite you to do this, try that practice, and then you can do day two and try that practice. But ladies and gentlemen, this comes out of our CCA book as well. It is section 2.2.2. And we do have to modify slightly some of the things that we're doing. It's unfortunate because the activity associated with this is really pretty cool. And no, I don't actually have you guys riding tricycles in the hallways of Park Center, even though that would be pretty fun. But just the teamwork part of this, the creation that surrounds this. If we could do this in person, it would be awesome. But we have some limitations. And again, please understand and respect those limitations because they're keeping people safe. So ladies and gents, what do we got going on? Well, we're again going to go after slope, right? But notice it doesn't say anything about slope here. It says rate of change, and we're going to investigate that slope as a rate of change in real world situations with context. And so it takes a difficult idea and it kind of turns up or dials up the difficulty a little bit more because we are including context. It's one of those things we got to remember. If we're going to do this well. Okay, so what does a rate of change represent, and how can we use it for the purposes of comparing, for describing, et cetera, et cetera. And we've got this this framed up in a trike race, and or a bicycle race. I'm sorry, I guess they're trikes. Typically, and this is true in the Olympics, it's true in like a track meet. If you've got a finals competition, that final is usually preceded by what they call heats. So you might have to make it to the finals because you won your heat. And that's what we've got going on here. We've got the first heat of several competitors that are racing against each other on tricycles. And in this heat, we've got Leslie, Kristen, and Evie, all starting at the same start line and riding trikes toward the finish line. And we've got some information here, and I'm going to try to document all this stuff using some different colors. So, might be a good idea to have some colored pencils or pens, but let's see what we can get out of this. All right. First and foremost, Leslie. Leslie began at the starting line and rode at a constant rate of 2 meters every second. So here's Leslie. Taking what we did in the last video, Leslie started at the starting line and rode 2 meters every second. So for me, she started at the starting line, which was 0, and she rode 2 meters every 1 second. Now you're probably already thinking, well, can't I just write that as 2? And the answer is sure. And can I get rid of that 0 there? Yeah, sure. Go ahead. So there's an equation for Leslie. All right, good. All right. Who else do we got here? Kristen. Kristen got an 8-meter head start. Let's use blue. Blue looks good for Kristen. Got an 8-meter head start and rode 2 meters every 5 seconds. So, Kristen, why do you think she got an 8-meter head start? Do you think she's a cheater? I don't know. Not sure. We'll see, I guess. Kristen got that 8-meter head start and rode 2 meters every 5 seconds. So again, I'm just throwing those blanks in there. 8-meter head start. She started 8 meters in front of the starting line, and she rode 2 meters every 5 seconds. So there's Kristen's equation that models her situation. And then we got Evie. Let's use green for Evie. Evie rode 5 meters every 4 seconds and got a 6-meter head start. All right, here's Evie. All right, y equals blank x plus blank. Evie was a 6-meter head start, and she rode 5 meters every 4 seconds, right? Distance per time. There's our rate. Okay, so there's our three situations. And in part A, it says, hey, on our neatly scaled axis, graph and write the equation in terms of x and y. Leslie travels. So I'm going to go ahead and go back to red here. And Leslie started at 0. And she rode 2 meters every second. Now, if that's enough for you to line this up on a ruler and draw it, go ahead. You might need more, so you can rise and run 2 from there as well. You can make as many dots as you need. But ultimately, we are doing something like that. The app that I'm using, thankfully, has a very, very neat tool for me to be able to do that. And now I'm looking at this. Did I make the right? Shoot, I did not. I'm sorry, I got to clean my line up. Let me try this again. Sorry, folks. Because I got to go to right there. There we go, that's better. All right, so there's Evie. I'm sorry, there's Leslie. Now we're going to move to Kristen. And we're going to go ahead and do the same for Kristen. Let's see, she got the 8 meter head start here, so her y-intercept is going to be 8. And then she goes up 2 and over 1, 2, 3, 4, 5. And up 2 and over 1, 2, 3, 4, 5. Maybe that's how you make that. I'm not sure. Whatever's convenient for you. Kind of get to be the boss of yourself there. Okay. And I asked you in the last video to start thinking about that. It's going to be important, and we're going to investigate why today. All right. So there's Kristen, and then finally we've got Evie in green. Evie got the 6 meter head start, and she goes. Let's see, 5 meters, 1, 2, 3, 4, 5, every 1, 2, 3, 4 seconds. So here's Evie. And again, I have the ability. Okay, so we've got it, and again, you see another point of intersection right there, which is all fine and good. All right, we've got our 3 lines graphed, and they are color-coded per the individual. So check this out. After how many seconds did Leslie catch up to Evie? Well, that's the exact thing I just had highlighted. All right, and what I can do is I can grab a different color. Let's grab black, and I can investigate how long it took her. And sure enough, I can say that that happened after 8 seconds, just because I dropped down on that, drop down to that time axis, and I can find that that intersection point. And then it says how far were they from the starting line after Leslie caught up to Evie. Well, my distance is going to be over here. And it turns out, how far were they? They were 16 meters. Is it meters or feet? I'm sorry, I don't remember. Meters. So I can go ahead and say after 8 seconds, Leslie caught Evie 16 meters from the start. All right, and the beauty of this is I can go ahead and I can confirm this algebraically as well, and I'll leave this to you guys here. What happens when you plug in 16 there? Oh, that's Kristen. I'm sorry, I got to do it for Evie. Green, Anderson, sorry. What happens when you plug in 16 here and evaluate? It's a skill we've been having you work since the start of the course. What happens when you plug in 16? All right, I know that 2 times 16 is 32. I'm sorry, I said 16. It's not working out because I'm not plugging in the right thing. Sorry. 8, we got to plug in 8. 2 times 8 is 16. Ding, ding, ding. And then, of course, 5 fourths times 8. Well, let's see. 8, 4. 8 divided by 4 is 2. 2 times 5 is 10. Plus 6. Hey, that's 16 as well, right? It works out. So there's the confirmation algebraically as well. The winner of the heat will be in the final. The race is 20 meters long. Who won? Use both the graph and the equations. We're going to use the graph because it's going to be the most time efficient now that we've made it. But I'll talk with you about how we can do this with the equations as well. Well, here is my 20 meter finish line, folks. Ask yourself which line, the red line, the green line, or the blue line, intersects that 20 meter threshold first, right? As I move from left to right, because I care about the shortest amount of time in a race, who hits that first? And it looks to me like it's the red line, right? So who wins that race? It's Leslie, right? And how long did it take Leslie to win that race? Well, you guys can check my work there, but if we drop right down from that that theoretical finish line, we can see that it should have only taken her 10 seconds, right? And 2 times 10 makes 20. So that really works out, right? If the race is 20 meters long, who won? Looks to me like Leslie won. And then how long did it take each participant? Well, Leslie, we know, as we just mentioned, took 10 seconds. How long, and I'll confirm this on the graph, did it take Evie? Evie looks like she came in next. And what does that look like? That looks like about 11 seconds. I'm not 100% sure. That might not be a whole number. All right. And then, of course, Kristen. Well, I'm off my graph over here. You can see that Kristen didn't even make it to the finish line. Who knows? Maybe she fell off her bike or something, or got flat, you know. Not sure. Okay. Let's see. The school newspaper wants to report on Kristen's speed, how fast she was riding. Write your answer as a unit rate. Well, ladies and gents, we're going to go ahead, and she has that in 5. I'm going to just go back up here and revisit what her speed was. 2 meters every 5 seconds. Sorry about that. Okay, this is not a unit rate. The reason I know that it's not is because I do not have a single or a whole number in the bottom. And the way that we would, of course, do this is we just actually do the division on a calculator. If you take 2 and divide by 4, we have 0.4. And that might look a little peculiar, but I have 2 meters per second, or 2 meters per 5 seconds right here. Well, that's the exact same thing as saying 0.4 meters per 1 second. This is my unit rate. And the reason or the purposes that we compare this or convert this into a unit rate is for the purposes of comparison. Okay, so I can go ahead and do that pretty quickly and easily. All right, we're going to do a similar style thing, and it is going to be in this next problem, 54, except we're going to kind of work backwards. So we've got the same setup, a tricycle race, but it's the second heat. Elizabeth, Kay, and Hannah raced down the track. They knew the winner would compete against the others in the final, and check this out. It says, when the line representing Kay's race is graphed, the equation is, and they give us the equation. So here, rather than giving us the situation, they're giving us the equation. They say, hey, what was her speed? Well, that's just the slope. 2 over 3, that's 2 meters per 3 seconds. And if you want to go ahead and do that as a unit rate, you can do that division and work out to be 0.6. And did she get a head start? Heck yeah, she got a 1 meter head start. All right, here's Elizabeth's equation right here. Who was riding faster, Elizabeth or Kay? Well, Elizabeth was 12 meters per 16 seconds, and that's initially a pretty tough or tall task. So this is why we care about that unit rate. If I take 2 and divide by 3, that gives me 0.6 repeating. Well, what's 12 divided by 16? Well, meters per second. Who's riding faster? Somebody's riding 0.6 repeating meters per second, or somebody's riding 0.75? That's our faster bike rider. Okay? Real quick, I can see that I want to get to the end here because I want to talk review preview before we hit 15 minutes. Just as she started pedaling, let's talk about C real quick. Hannah's shoelace came untied. Being careful not to get her shoelace tangled in the pedal, she rode slowly. Hannah's race is represented by the table below. At what rate is she riding? Write your answer as a unit rate, folks. We've got x1 and x2 and y1 and y2, and we can go ahead and calculate slope from a table there. So I can do y2 minus y1 over x2 minus x1. That works out to be 4 over 14. And I can do that. This one's going to be a little tougher. So I'm going to use a calculator here because I don't recall the exact decimal off the top of my head, the decimal of 2/7. I grab my calculator, I type in, and I get 0.28. And I'll use my about equal sign to represent that. Meters per second. Okay? A little bit of review preview, and it's just a couple problems. And if you need graph paper, or if you need the ability to do some graphing and you don't have the graph paper, go ahead and make a sketch, folks. Okay? Go ahead and make that sketch. Ladies and gents, thanks for your time. Thanks for watching. Have a great day.